this is about how we take Joel's team, that product, and make the LF 2008 from the LF 2001. And yeah, I'd like to recognize this is basically the team, Gretchen Meyer, Natalie Jeffner, Stidlitz, Fell, kind of assisting in this. Yeah, so there were basically, this is kind of the overall outline. We kind of had to, the first thing we do is look at as Joel said, I think he was talking, kind of pointed more toward the 2008, 9, and 10, which we'll be using in the LF10. For refresh, we produced 10 layers, or 10 years, 99 through 2008. So you've got 10 individual layers of disturbance data. And for our process, and a lot of this kind of tracked back to the fields team, really put a lot of the idea behind this in place to update the fuels, and then we just transferred it to the veg back in the early days of refresh. But one of the things that kind of was said at that time was to collapse that 10 years of data, those multiple events, into one layer that we could then identify the disturbance and the time since the disturbance and the severity. And I'll talk about some of the background databases we use. So we've got a set of forest transitions that we preload, derived from FES and FFE, and then a kind of a rule set driven non-forest transitions. And then, yeah, just kind of a real quick, it's really just a access, update, query process, but then I'll show a series of slides that kind of visually, a picture tells 1,000 words, and I'll visually walk you through how we go from 01 to 08 in a small area in Oregon. This is kind of the flow chart, a subset of it. So this shows you, we've got from the LF 2001-8, the improvements from the EVC, and the EVT coming in. We build our stack of the circa 2001 data, and that goes right on to the fire behavior, fire effects, and fire regime products. And then we're bringing in the disturbances, as Joel alluded to. We're using MTBS and events. We've substituted MICA for DCT, creating these disturbance grids. They come in, and basically we've got a non-forest forest process. We've got a little bit of legacy from the VDDT models. We mined some of the non-forest kind of outcomes from, and then a big effort to run all these plot data that we have, tree plot data through FES and FFE to help inform our forest transitions. Run through the transitions, and then we've got a stack of circa 08 products that then move on to map fuels, fire regime, and fire effects products. So this is some of the kind of dirty details of 10 years of data. What we kind of determined early on, that from a transition standpoint, we really can kind of work in groups of years. So 1 year since disturbance, a kind of a 2 to 5 year period, and then a 6 to 10 year. So we basically group 99 through 03 disturbances into one bin, and 4 to 7 into another bin, and then the 08 into another bin. Now, one thing we have thought, and might have, I don't know if you were, we just went ahead, last one in one, and about 90% of the landscape didn't have more than one disturbance. But now that we look at our data, we're seeing that some places where we had multiple disturbances year after year, the last one in maybe isn't such the best answer. A lot of salvage logging and a burn, so that we lost the burn. But we want to, so something we're engineering for LF10 is to let the burns come through, establishing a cleaner priority. But we felt like these kind of bins, and I think these kind of originated again from the fuels team, just from a 2 to 5 years. I just seemed more intuitive. Certainly 1 year after disturbance, we want to represent in LF8, the 08 clear cuts and 08 fires. Want them to be just more or less grass and shrub. And then the next step, we let some growth come in, and then the 6 to 10 years let some growth. I think you said, Tobin, that the 6 to 10 year for the fuels, you guys didn't even bother with. You just
you went for surface fuels 0 to 5, and then 5 to 10, and then after 10 years.
After 10, right. And then at this point in time, we take the disturbance types, the more kind of detailed event codes, and roll them up into broader types. So we group all the fires into fire. We have a series of mechanical remove, so it has implications from what surface fuels are left versus a mechanical add. And then we've got wind throw, insects and disease, and then chemicals and herbicide. So now we're working with, what do you have there, 7 disturbance types, 3 times since disturbance. And then the severities pretty much stay the same. The severities that come through process Joel is talking about, high, moderate, low, track through as well. So we kind of have a 3-dimensional look with one map, and that's what we call our VDIST map. So we can basically then look at the coding. 131, the first number is the disturbance type, and the second one is the severity, and the third one is the TSD. And that becomes just kind of one mushed up layer. And this, like I said, for LF10, we're looking at a little more eloquent ways to let the fires come through. We're also seeing in the events data that some of these disturbances take place over a 2 or 3 year period. So you might find they did like a moderate thinning, and then the next year they piled and burned, and then the next year they did a prescribed fire. And in our process now, we're kind of doing, from Joel's standpoint in the events, we're getting a good snapshot of that 1 year at a time. But when we roll it up, what we're kind of grabbing is that, well, they just did a prescribed fire, and we lose all that information. So trying to look at ways to kind of step back, and we could probably look at that whole process and say, oh, well, that's probably a mechanical remove, so that's what needs to go there. But just some weak points in the system that we're trying to work out. So I guess in a nutshell, what we have to build up front are what happens after the disturbance, and we've kind of bifurcated things, forest, non-forest. And on the non-forest side, it's really a process of kind of working through simple rule sets that address a number of different issues. We have to deal with non-forest EDTs, so shrub and grass, that potentially could be succeeding to forest. They sit there for 10 years, they don't get disturbed. Some of them are moving into trees. Some places, we sit there in Montana or Nevada or maybe eastern Oregon, and it's like, it doesn't happen much. Well, in your part of the woods, Roger, Pacific Northwest or the Southeast, clear cuts are covered in within a year or two, and in 10 years in the Southeast, those trees are 20, 30 feet tall, so it's not a trivial thing. So succession backfilling on the forest side is an important deal, so we work with that. We don't really deal with any succession on the rangeland side, no grass moving to shrub, and so on and so forth. The other issue we have to deal with is even in forests, high severity fires and mechanical removes are going to take us to a non-forest EVT. And really that's something FVS, FFE doesn't really work with very well. It doesn't predict our EVTs. In fact, all you get when you do a stem replacing fire in FVS, you get a -999 as your forest type because it's not a forest anymore. So we kind of have to substitute our own little rule sets in here and track those. And so we implement those, any high severity fire and any mechanical remove. And then we try and parse it out. Like if you think about some areas, that same non-forest EVT could persist for 1 TSD, 5, 10 years. Some places you might only want to let it persist for 1 year, and then in the next year you want to let FVS backfill it. So a little bit of differential assignments. And then we have a whole slew of the next 3 are just what happens to grass and shrublands after they get burned and to some degree mechanically disturbed. And then we're also implementing chemicals and herbicides, but really the only place they can apply is if our EVT is an exotic grass or forb, and we just change it to a native grass or forb. So the outcomes, we did mine from the S-class layers and VDT, matching up the EVTs, non-forest EVTs with the similar BPS, and we asked the question, what is the general S-class EDC and AVH? So that's generally what we backfill the resulting non-forest transition with. And then to a large degree, we kind of had to work within each map zone to backfill non-forest EVTs with non-forest EVTs that already occurred in the map zone. And to some degree, there was a logistical thing. We didn't want to make new EVTs for the fuels guys, but in a sense, what we find happening is that the circa 01 layer is kind of a, there's a legacy of disturbance on the landscape. So you can look at these non-forest EDTs that are growing in clear cuts and burned areas, and that's probably what you want to backfill the new ones in. So there's kind of a legacy of disturbance that suggests what you should be using. So that was just more or less the logic we worked through, set up a series of tables. They're prepared to fill in the non-forest transitions. Forest was a little bit easier in a sense that we have this model called FDS, and when it's linked up to FFE, it can work with fire, and we can run tree plots through it and do all kinds of things with it. So basically, in a nutshell, our process was to take all our tree plots, prep them up for FDS, FFE, run them through all these different types of disturbances, and I'll go through that in the next slide, bin the outcome into different EDC, into the EDCH classes they come in, or come out as, and then we kind of work with a grouping where we group the inputs, so we can basically link that output with every EDT, EDC, EDH combination on the landscape and disturbance. So basically we have a strategy, so no matter what burns in a high severity, what EDT, EDC, EDH is, we've got a new EDT, EDC, EDH to put it into. Kind of work with the majority, a lot of times you might have 50 plots that started out as one EDT, EDC, EDH, and you did a moderate thinning, and what we found is most of the time it was in EDC class, like a trying to think like a 105, but maybe 40 plots were in a 103, and we just took the majority. You see a range of things in there, but we decided to do a majority outcome. Some of the things we considered was just doing a % change and multiplying that back in there. But in the end, we have a whole set of forest tables ready to kind of populate the landscape. This is some of the specifics. These were actually designed by Charlie and Tobin, the kind of simulation parameters. For our mechanical remove on high, we kind of simulated a clear cut and burn. So this is the specific kind of KCP file level information we had to give FBS. Moderate mechanical remove was a 35% removal in the pile and burn, and then to get the low was a thin from below, and the 0 to 6 in a pile and burn. Mechanical add really just from a high, moderate, low, we went 90, 75, and 55 with a 0 to 8 inch material, and then just masticated. So then in FBS, we can say, well, what AVC, EDH do we end up after every one of those? Similar for fire. I guess fire ended up being a little trickier because you can't really dictate what the outcome is. You kind of have to model the input to get the outcome. So you have to dry things out and push the wind up to get high and moderate and low severities. But in the end, you can look at levels of mortality and kind of see how well you're doing. So we were targeting like 95, 75, and 40% mortality in these simulations. And then insect and disease and wind throw are a little more straight ahead. You just kind of code in fixed mortality at different levels. Everything just stays there, falls down and stay there. There's no site prep or anything like that. And then similar for wind throw. Although I think that was more of you actually thinned it. Is that right? And then just left the trees. So these are just things to make FVS do what you want to do to simulate what all that stuff is occurring on the landscape. And then really a fairly simple process where we overlay that VDIS layer on our circa 01 EBT CVH, and export that as a database, bring in these different tables, and then really just run an update query. We update the circa 01 EBT VCVH to a new one, depending on the disturbance type, severity, time since disturbance, and then really just run an update query, export it, link it back to the grids, and crank out the circa 08 layers. More or less the forest focus on EBT or EBC and EBH changes, and if it's moderate or low severity, you don't get any change in EBT. We considered going back and seeing, well, is the EBT changing, but that would involve like running the new tree list back through the sequence table, and I think in the end, fairly early on, we said, if you just moderately change or low change in the stand, it's the same EBT pretty much. Only life form changing things that we go to a different EBT. So I'm just going to go through a kind of a quick example of a landscape, and Chris might recognize somewhere in eastern Oregon. This is the nape imagery, and I found a good metric to follow is the EDC layer here. So you've got the kind of a gradient of green, dark to light green for the tree cover, these kind of brighter orange are herbaceous, and this kind of more dull brownish orange are shrub classes, and then there's quite a bit of just agriculture and hayland and riparian wetland in these creek bottoms. So as Joel showed, first thing, this is just the kind of give you an idea of the level of data we get. This is the events data, just colored in magenta. There's not by different type. This is an idea what the MTBS data that came into that area, and this is kind of coded for severity and year, a random color scheme. I put those two together, and we're also merging in the VCT or the mica outside of these, and this is the kind of give you an idea of the VDIS layer. So, you know, one of the interesting things here's a big herbicide treatment that came into the events polygon. Probably not the exact perimeter of where they treated, but it's probably some administrative unit that in the facts data on the Forest Service side, they said we spent some money here and we did something. And similarly for some of these areas outside the MTBS clear cuts, you know, and Joel showed you some of that. So this has been yarded up to where now for every pixel we have one answer, one disturbance type, one TSD that yards up those years, and then one severity. And then this is basically we're preparing to kind of translate our transition process into a map, and it's fairly easy to do because when in that update query, when we changed the circa 01 EBTBCH column to circa 08, we can also just leave a code behind that says this is what we did here. We updated this, we increased the cover for the succession, or we decreased the cover for fire. So we're designing we've got a legend design, and we're actually preparing to kind of attribute all these zone databases we ran through and put out a product so you could actually kind of look. I've just colored these in as one value, as one color, but the idea is to kind of expand that legend to say, okay, well, right here we did this was a high severity fire, so we'll have disturbance type, and then we'll say there was a moderate decrease in cover, or there was a life form change. It went from tree to shrub. So you'll be able to, it'll be just physical evidence of what we did. You know, it seems like there's a lot of interest in this. So in these yellow areas and then the orange, there's something happened. And like I said, there'll be a full legend that'll kind of along with it. And then here's the resulting EBC08. So you can kind of see that those yellow areas, which where we transition, you know, coming from, back with our VDIS layer, they were disturbed. We transitioned them. Now the EBC08 is different. And then I just threw EBC01 back in there, so you can kind of toggle back and forth, and you can definitely see landscape change. It's modeled landscape change, but it's landscape change. And you know, and to some degree, large degree, it makes sense. I think some of the things we're seeing, as I mentioned before, that double disturbance. I think this time around we were kind of conservative on some of the lasting effects of fire and the mechanical harvests in some of the dry types. That 6 to 10 year TSD, we tend to backfill that with the FES, which backfilled with a lot of trees, and I think in some areas we're still seeing, at least on the high-res imagery and whatnot, I'm seeing, you know, a pretty good footprint of the fire. Hard to say, though, if you were to go on the ground, there might be 10, 20, 30% cover of trees, but they're all about a foot tall. So hard to say where things are at. But I think this time around we might be a little more aggressive. You know, kind of, I don't know if we'd exaggerate the effects, but just make them a little more obvious and probably backfill a lot of stuff with non-forest. Now this is the last slide. I'm just kind of alluding to the circa 10 process. What's a little bit different, as Joel talked about, we're going to bring in this is the stack that they're working with to get it a 8, 9, and 10 disturbance layer. You need five Landsat scenes, so we're going to bring in the 8, 9, and 10, which I don't have here. We'll actually put it back on the 99 through 2008, replace the 8, drop the 99 and 2000, so we'll have another stack, 10-layer stack, and it'll go into this process and then travel on to the LF 2010. But really not a whole lot changing from that other flow chart that I showed you. I think we're just, what the other thing is, we're probably going to be able to operate at a geo area level, which is upwards of 12 map zones. This first effort we just did it one map zone at a time, and we're kind of building in ways to track where we can, even within a geo area, we'll know the map zone, so we can kind of control what we're backfilling things with. That's about it.